Okay, we'll start today's class from 11:30. We'll wait for 5 more minutes for everybody to come. So it's 11:28. I hope I'm clearly audible and visible. I'll start the lecture on 11:30. If I'm not audible and visible, please let me know through the chat, or please do WhatsApp me if anybody has my WhatsApp number. Okay, thank you, Harshita. Okay, let me start because this is live streaming and my voice is a bit late when reaching to you. It's a bit late. See, until now we have studied about graph representations, BFS, DFS, and shortest path techniques. Okay. Now, what we are going to learn today is about spanning tree. Now, the first question may arise in your mind, what is that? Okay. Now, the spanning tree is obviously it's a kind of tree which is created from a graph. Okay. A graph and a tree both are nonlinear data structures. So, when any subgraph of a graph is containing no cycles, no closed paths, okay, that part, that subgraph is called spanning tree. And also, the spanning tree will connect all the vertices. Okay, a graph G can have multiple spanning trees, which will contain all the vertices, and obviously it will be connected. It will be treated as a tree, and it won't contain any cycle in it. Okay, that will be called a spanning tree. See, we can see in this picture. See, this is a graph. Let me do the slideshow so that you can understand. Okay, this is a graph. Okay, the total graph is containing 8 vertices and several edges, isn't it? So, if we consider the red parts, only the red lines, that is a spanning tree. Okay, why that is a spanning tree? See, the red lines, these red lines, the red edges are connecting all the vertices present in this graph. 1, 2, 3, 4, 5, 6, 7, 8. But it is not containing any cycle. Similarly, for the same graph, we can consider, see, another one. This red lines will contain all the vertices, but it won't have any cycles or loops. So that is called a spanning tree. We can consider it as a tree because a tree doesn't contain any cycle, any loop or anything. Correct? Next, minimum spanning tree. So, in case of spanning tree, what we have to do, we have to consider the total weight of the spanning tree. Weight of the spanning tree can be considered as the summation of all the edges in the spanning tree. Suppose this one, this red one, if we consider the red lines, see, similar graph can have more than one spanning tree. In this is two graphs, two same graph. This one is same, but still the spanning trees are different. But the minimal one, in case of minimal one, what we have to consider is the summation of the edges in the spanning tree. Suppose in this spanning tree, we can consider what is the total weight of the spanning tree will be 3 plus 5 plus 12 plus 9 plus 4 plus 6 plus 1. All the edges, all the weights of the edges will be considered and summed up to find out the total weight of the spanning tree. Spanning tree. So similarly for this spanning tree, what we have to do is 5 plus 3 plus 4 plus 8 plus 1 plus 4 and plus 6. Okay. So spanning tree has properties that it won't contain any cycle. It will contain all the vertices without cycle, and the minimal spanning tree, which one, what is the total weight of a spanning tree, will sum up all the edges, weights of the edges, and then we can say that this is the weight of the spanning tree, and if the weight is minimum, that is called the minimal spanning tree. Clear? If the edge weight is minimal, now we can say, you can say that, ma'am, how can we consider the minimum? Which one is minimum? There are several spanning tree can present, which can include all the vertices and not include any cycle, right? So there are two algorithms which we will study today, Prim's and Kruskal. First, we'll study Prim's. See, follow me correctly. you can get the Prim's algorithm. I'll repeat it if you don't understand. First, this is a graph. So first of all, you have to keep in mind that this should be a weighted graph and undirected graph. In case of spanning tree, weighted and undirected graph. Okay. Next, yeah, I can explain from the beginning. Obviously, spanning tree. I was telling about spanning tree. If there are any graph, if there is a subgraph, this is a subgraph, the red lines contain a subgraph of the big graph. If that is containing no edges, which is creating any cycle, and which is containing all the vertices of the graph, is called a spanning tree. In case of any spanning tree, any tree cannot contain any cycle, right? So, in case of spanning tree, why it is called spanning? It is spanned through a graph. It is a part of a subgraph. A part of a graph. That is why it is called a subgraph. If a subgraph of a graph which is containing all the vertices and containing no loops or no cycles, that is called the spanning tree. Okay, and how the spanning tree, weight of spanning tree can be calculated? By summing up all the weights of the edges. Okay, all the edge weights we can sum up and we can call that is the total weight of the spanning tree. Now, what is minimal spanning tree? We have to find out minimal one, which the weight of which spanning tree. Suppose a graph is having 3 or 4 spanning trees or more than that. If there is one spanning tree which has the least minimal weight, 1 or 2 it can be depending on the weights. So, that is the minimal spanning tree. Clear? For minimal spanning tree, you can understand when we are doing the algorithm, there are 2 algorithms, Prim's and Kruskal. We can find out through the minimal, how the minimal spanning tree are calculated. We can tell that. Okay. Let me tell you, then you can understand. Okay, show. See, this is a graph, undirected and weighted graph. We can start with any vertex. Okay, we can start with any vertex. I'll start with B, you can start with A, you can start with C, doesn't matter. Okay, just start with any vertex. I'll start with B. This is my first vertex which I am visiting. First, what we have to do is, we have to see all the adjacent edges. Now, B has 2 adjacent edges here, BC and BD. Clear? We have to take the minimum edge. Okay? If any vertex is having n adjacent edges, we'll consider just one edge which is the minimum one among all the adjacent edges. Here B is containing 2 adjacent edges, BD and BC, and we are this one and this one. I hope you know about adjacent edges, the neighboring edges, like, okay. So now BC and BD, so B will consider BD. Why? It is having the weight 4 and it is having the weight 10. So obviously 4 is less than 10. We'll consider the edge weights and we'll consider the minimum one. So this will be added in our spanning tree, minimum spanning tree. This will be added in our minimal spanning tree, this edge. Okay. Follow the red ones. Okay. Now, D is our new vertex which we have to explore. First we have explored B. This was 1. Now number 2 vertex which we have to visit is D. Now D has 3 adjacent edges. We can see that. Number 1 is DE, number 2 is DC, and number 3 is DB. But already it is an undirected graph. So what the edge which is BD, that is only the DB. So we cannot consider the edge which already has been visited or included. Okay. So now we have only 2 edges. And one more thing I would like to tell you, that we are considering BC also, but we'll consider it later. We have visited it but not considered it in our spanning tree, but we'll consider it later. How? I'll tell you. Okay. Just keep patience. I'll just explain you. See, this is D. D has DE and DC at adjacent edges, and now we'll consider the minimum one. Same process. Okay. Which one is minimum? Obviously 1. It is containing the edge weight 2 and this is containing the edge weight 1. So this will be considered as in our minimum spanning tree. This will be considered. Clear? Now, our next vertex, new explored vertex is C, isn't it? Sorry, C, not C, it's E. E we have explored, so we will see the neighbors of E. Now, adjacent edges of E. So, E has only one adjacent edge which is not visited. DE is already visited. So, now an interesting point is coming up. See, for exploring C, vertex C, we have three options now. From BC, from DC and EC. Okay. So, we have to consider all the possible ways how we can explore C, and we have to take the minimum one. Clear? Not clear maybe. I am repeating. Okay. Shall I repeat this? I am repeating. Okay. Maybe it's clear, still I am repeating. When we are considering C, first we have considered B. BD and BC was the adjacent vertices, adjacent edges, and BD was the minimum one. So, BD was considered in the minimum spanning tree. Next, for D, DE and DC was the unvisited edges. So, we can say that DE will be considered as it is the minimum one, considered in the minimum spanning tree. Now, E is our new vertex. E has only one unvisited edge, that is EC. But for exploring C, C is already been explored, can be explored by B already, B or D or E. So, we have to take all the possibilities of exploring C and take the minimum one. So, for that what we have to do? Keep track all the visited edges, edge weights. Okay. So, we will consider this edge in our minimal spanning tree, not this one, not this one. Clear? And not this one. Among 10, 2 and 6, obviously 2 is the minimum one. That's why I am considering this. Now, after exploring C, C has only 2 adjacent edges, 10 and 3, BC and CA. So, obviously we will take the minimum one. And now, this is how we can consider the red lines are our minimal spanning tree. This one. This one is our minimal spanning tree. Okay? Is it clear? I hope it's clear. I am repeating once more so that you can understand it clearly. First, we will start. Again, I am repeating by discarding all the colors so that you can understand it clearly. Very easy. Very easy. Nothing is very complicated over here. Start with any vertex. I am starting with B's. You can start with any vertex. So, this is our first vertex. We will check on the adjacent edges BD and BC. We will take the minimum one. 4 and 10. We will check the weights and we will take the minimum one. 4 is taken. Yeah, 2, 6, 10 are edge lengths or edge weights. Weighted graph this is. So, this will be edge weight. Okay. Last day I have taught you that edge weight, what is weighted graph? Okay. So, 4 is taken in the minimal spanning tree. Now, next vertex is D. D is first we will take this one in the minimal spanning tree. Okay. Now, next second vertex is D, which we have to explore. That has 2 adjacent edges which not been visited, which hasn't been visited yet. DC and DE already. Okay. You have got it, fine. So, already I have told you, you have to take the minimum one. So, 2 and 1. So, 1 is minimum one. So, we will take D in the minimum spanning tree. Now, if we come to C, for E, this is the third vertex. We have to explore the adjacent edges. So, it has only one adjacent edges which is not visited. Okay. But for exploring C, we can see that already we have visited 2 more options. EC is here, okay, it's fine. But DC and BC is also here. So, we have to take the minimum way. Okay, minimum edge weight. So, among 10, 2 and 6, which one is minimum? Obviously 2. 2. So, we will take this edge and discarding other 2 accordingly. Okay, we won't take this one and this one. Clear? And now our fourth vertex is C, and C has only two adjacent edges, BC and CA, and we'll take the minimum one as I have told you earlier. So this, and now we can see no more edges and no more new vertex are rest to explore, to be explored. So we'll stop here, and now this way we can say that this is our minimal spanning tree. If someone asks you to what is the total weight of this spanning tree, what we have to do is we have to sum up all the edge weights. That is, in this spanning tree what we have to do is 4 plus 2 plus 1 and plus 3. 4 is the weight of BD, BD. 2 is the weight of DC. 1 is the weight of DE. And 3 is the weight of CA. And one more thing we need to concentrate on is if any vertices or any edge has a minimum weight but it is creating a cycle, then we cannot take it. Then we have to take the higher order edge. Maybe the weight is greater, still we have to take that edge which is not creating the cycle. If any edge is creating a cycle in minimum spanning tree, that won't be considered. We can see that in the Kruskal algorithm that you can understand. Okay. So the total weight of the minimal spanning tree is 10. If someone asks you, this is the process. You have to follow the steps and draw the spanning tree and write down the total weight. Here the steps has been shown and steps are written also. Okay, written also. So no matter if you forget that, see my lecture and follow the PPT, you can solve it. Now the Kruskal algorithm. This is another one. This is very beautiful, very easy. Okay, what we have to do in Kruskal algorithm is, first, this is our graph. First we have to take a table. The table which will contain all the edges and corresponding edge weights. Okay, all the edges and corresponding edge weights. Clear? Now we have to sort the table from minimum one to the maximum one. See, AB has the minimum weight and AD has the maximum weight here. Clear? First we have taken the graph, created a table, that is, maybe that can be called as the weight list or weight table or something. Age wise corresponding weight can be written in this way, and next we have to sort it. Now one by one we will add all the ages, if keeping in mind in one condition is that is not creating any cycle and visiting vertices. Okay, let's start. First one is AB. AB is our first vertex. Okay, first edge. Considering AB, not creating any cycle, considered. Okay, next one is DE. See, in this table, DE is next one. Not creating any cycle, considered. Okay, third one is BC. BC, not creating any cycle. C, not creating any cycle, created. Fourth one is this one is third one. Okay, and fourth one is CD. See the table, CD. CD, not creating any cycle and connecting the graph, and we have got all the edges. This one is 4. Now, if we consider the rest of the edges, AE, AC or AD, suppose we are considering it. See, if we add AE, see, this is creating a cycle. No cycles are allowed in minimum spanning tree because this is a tree. No cycles can be here, right? So AE will be discarded. So we'll discard this. Okay. Next. AC. AE is discarded. AE we have already discarded as it was creating a cycle. AC. Suppose we are adding AC. See, again cycle. A, B, C, A. Again we can return to A. So this is also a cycle. We cannot consider it, right? So we'll erase it and discard this edge, right? With discarding AC. And now in case of AD, again we'll have, see, AD. If we add it, see, we are adding AD, see, again a cycle. Again it is creating a cycle. So this can't be happen, right? Because no cycles are allowed in the minimal spanning tree. So we have to erase it and discard the edge. So this is our final minimal spanning tree with 4 edges. Now if someone asks you that what is the edge weight, total weight of the minimal spanning tree, what will be the total weight? Summation of all the edges, that is 1 plus 2 plus 3 plus 4, that is 10. Clear? I'll repeat. Okay, shall I repeat this one? I'm repeating. Okay, no matter you have understood or not, I'm repeating. Okay, first what we have to do, see the graph, make a table, keep in the table every edge name and corresponding edge weights. Next step is sort the table from minimum one to the maximum one. Next, one by one, we will consider all the edges which is not creating any cycle. First one is AB. AB has been added in the minimal spanning tree. Second one was DE with edge weight 2 is considered as it is not creating any cycle. Third one was BC with edge weight 3. Okay, not creating any cycle, no matter, no issue. Fourth one is CD, not creating any cycle and being connected with the graph. And rest of the AC, AD and AE, 3 of them are creating cycles. So we cannot consider them. So this is how our minimal spanning tree is being constructed by Kruskal algorithm. Okay, is it clear? And how, if someone asks you that what is the total weight of the spanning tree, you can say that the total weight is all the summation of all the edge weights of that MST. So I hope it's clear to everyone. Shall I repeat the whole session? Please respond in the chat box. Okay, everything is written here. Okay, everything is written, all the steps are written. First, okay, I'm repeating. Okay, if you are not, I cannot see your response as maybe the network is slow. So I hope it's clear to everyone. I'm just repeating this one. Okay, okay, you got it. Okay, Simran, you have got it. Still, I'm repeating the prims and Kruskal. First, what we have to do, just follow me. First, we have to start with any vertex. Clear? B, I have started. Okay, I am discarding all the pointer options. See, I have started with B. Check on the adjacent vertices. Okay, check on the adjacent vertices. Take the minimum one. This one is the minimum. Okay, this one is minimum. And check on the weights. Okay, weight of the edges. Okay, next, new explored vertices is D. So adjacent edges of D is DC and DE, and DB is already visited, so we can't consider that. So take the minimum one, which is 1. Previously it was 4 because among 4 and 10, and now it is been 2 and 1, so we'll take this one. Now this one is the third vertex which we have to explore the adjacent edges. So for EC is there, but for exploring C, we have already encountered two more options, that is BC and DC also along with EC. So, we will consider the minimum one among all those options, all the possible ways. So, among 10, 2 and 6, the possible ways, edge weights, which one is the minimum one? That is this one. So, we will consider this edge in our minimal spanning tree. And again for C, which is our fourth vertex, which we have to explore, that is there are two edges adjacent. We will take the minimum one among 10 and 3. Obviously 3 will be considered. Just keep it in mind, if there is any vertex that is not having the minimum weight, that is having the minimum weight, but it is not, satisfying the condition of no cycle, that edge will be discarded. Even if it is having the minimum one, still it will be discarded, but because if we add it, it will have some problem with the cycle. Okay. So that was our Prim's algorithm. Okay. Now for Kruskal, what we have to do is create a table with edge weights corresponding to the edge names. Next, sort them accordingly from minimum one to the maximum one, and next, one by one add them. Okay. First AB is added. AB is the first one here. AB is added. Next, DE is added. Just keep it in mind. We have to keep in mind one condition, that is no cycles are allowed in a minimum spanning tree. It's a tree, no cycles are allowed. Okay. Third one is BC, no cycles are there. So adding BC, and next one is CD. Okay. So add it, and any other edges other than these are creating cycles, so we are discarding them. Okay. So, and how the total weight can be calculated? Summing up all the edge weights of the edges. Okay. And now one more thing, spanning tree, the definition of spanning tree, what I have told you earlier, that it will contain all the vertices of a graph. Spanning tree will contain all the vertices of a graph. It will contain no cycle, and preferably in case of the sum of minimal spanning tree, it will be an undirected weighted graph. Okay, it will be an undirected weighted graph. Okay, in exam you are given a graph, you will asked to find out the minimal spanning tree by following Prim's or following Kruskal. You have to show all the steps. Likewise, I have shown you. Okay, one by one. In this PPT, I have shown you all the, all the steps, how you have to solve a minimal spanning tree problem. Okay, so just keep it in mind. If you are drawing directly the minimal spanning tree from the question, you are seeing the question and you are just solving that directly, you are keeping that answer, that won't be considered as your answer. Okay, you have to show all the steps. Otherwise, how can we know that you have followed Prim's or Kruskal? You have to show all the steps of Prim's, either it's Prim's or it's Kruskal. Okay, and one more thing, minimal spanning tree has the least, total weight of the spanning tree will be least, the minimal one. Why it is not minimum? It's minimal because there can be more than one minimal spanning tree. Spanning tree can be more than one, that is so okay. Okay, right? That is okay with you. You can understand that easily. But in case of minimal spanning tree, if there are multiple weights, similar weights, like if there is 1, 1, 1, 3 times, 3 ones can be considered, or any other minimal spanning tree, 2 ones can be considered. So minimal spanning tree can not be unique also. Okay, may be unique or may not be unique depending on the edge weights. Okay. So that is that. So that was today's class, all about graph, and I hope all the things related to graph has been covered. In this lecture, we have completed the graph theory. Okay, graph theory. Obviously I'll give the PDF, not PDF, PPT. I'll give the PDF in the Telegram group for all the sections. For all sections I have taught you already. graph representation I have taught, BFS, DFS I have taught, shortest path is taught by PDC madam, and now minimal spanning tree has been explored. Okay. So if there is any question, you can ask me. I'm here only, and you can contact me on WhatsApp also if you want, and I'll give you the PPT after the class. After the class, I'll definitely provide you the PPT. I hope everybody understood the concepts. First, what we have studied today, spanning tree. What is a spanning tree? Spanning tree is a tree or a part of a graph which can be called a subgraph, which is containing no cycles and which is containing all the vertices of the graph. Okay, not all the edges, only vertices. All the vertices will be covered, and which is what is the total weight of the spanning tree? If that is a weighted graph, we have to sum up all the weights of the edges and we can calculate the weight of the spanning tree. And what is the minimal spanning tree? The least one, the minimum weight will be called the minimum weight containing spanning tree will be called the minimal spanning tree. So a graph can have, same graph can have more than one spanning tree, and if the weights are similar or the paths are similar, depending on the weights and paths, it can have more than one minimal spanning tree also. That is why it's called minimal, M-I-N-I-M-A-L, minimal, not minimum. Okay. So that is the difference between minimum and minimal. If there is more, there is no unicity there. If there is only one, if suppose I am telling you which one is the youngest student in your class. So there can't be, because many of you are in same age, right? So the minimal weight can be calculated. Say it's 20 or 21, whatever. But minimum weight cannot be calculated because more than one student can have the same weight. So that is the difference between the word minimum and minimal. Okay. So that was today's class. If you ask any question regarding this, you can ask. 2 algorithms we have studied today. How to solve the minimal spanning tree. Steps are written. I have explained you both, and I hope it's clear to everyone. Okay. I'll provide the PPT definitely. All the best for your exams. If there is any question, please let me know. I'm here only. I've given you the attendance link. So please give your attendance. If there is any question, please let me know. I'm here. Classes will be held during Kali Puja. See, I can't tell you anything about these class schedule. Please ask any senior faculty or HOD sir regarding this. I don't have any idea about classes schedule. Anything else regarding the topics of today? All the very best for your exam. Study hard, and this is your midterm 2 are coming, and midterm 2 is coming, and next semester is also coming. So, and graph is a very essential part of data structure, so you have to study hard. Okay, you have to be clear with the concepts, follow the PPTs. Okay, all the best. Okay, then I should stop streaming right now. Okay, all the best. If there is any question, please let me know through WhatsApp. I've waited, but no one is asking me any questions. Okay, then all the best.